Okay, this is intended as an instruction book video on the use of the data viewer that accompanies the CTMP 2020. This is an easy and convenient way to display your data and look at it, analyze it, whatever you need to do. First thing I'm going to do is I have the flash drive in there. It's been in there since I booted it. I have performed tests of 3 CTs in simulating A, B, and C phase on a breaker. I'm going to press the copy button. It will now copy the data for these 3 CTs to the flash drive. Okay, I have inserted the flash drive into the PC and kind of refocus things here. What I can do now is I can launch the CTMP 2020 data viewer, and I can open that file. It's a removable disk E. There's the file. It's named XFER, XXXX. And right now would be a good time to rename it so I can identify it later as part of the job I'm doing. Like with CT and the number of the breaker or other information that lets me know what this file applies to, what set of CTs. Okay, I'm going to open it, and I can add a note. I want people to know that this is Las Vegas substation breaker 230 and all that. So I type in Las Vegas substation breaker 230 ABC, all 3 phases, 2000 to 5. Save note. The note is now appended to the file. Okay, I've done a winding resistance test. This only allows for one winding resistance test. If you really want the exact winding resistance of each phase, you can do a separate file for each phase. But we'll say the winding resistance is 0.511 ohm. If I hit the 2 there. Okay, I'll save the winding resistance. The burden resistance is, say, 0.877 ohms, so we're going to save the burden resistance. Over here, it now calculates the accuracy limit factor. The winding resistance scale is the part of the winding being used. If I'm using the full winding, which I measured the winding resistance of, it's 1. If I'm using half the winding, it's 0.5, of course. As I tab through the data, it applies the winding resistance scale and the saturation voltage and calculates an ALF for each tap. Notice I have the graph of the saturation curve up here. Notice it doesn't go all the way down. It don't start till it reaches like 30 milliamps or something like that. There's no point in knowing what the voltage is at 2 milliamps or something. So I can, the red underline tap, 1999.4 is what it read for 2005. I can tab through, this is the next tap, X2, which is the blue tap on the test set, the data for that. Notice as it passes the IEEE saturation point, the numbers turn dull red and bright red when it gets to the IEC point. And you can use the tab button to tab through all the data. This is a 3-phase test. I can go to B phase, click on B phase turns red, and the same thing is available on B phase. Likewise, C phase. There's X4. Notice that the underline indicates which ratio this applies to. If I click on the graph, since log-log graphs are sort of compressed, I can click on the graph, and these numbers up here will give me the current and voltage at that point, more accurately than I could probably interpret it by eye. Where I clicked, for example, was 0.051 amps and 263.027 volts. And that is about the overview of the file transfer method. Note that this data viewer can be sent on a flash drive or a CD with the customer's data, or the end user, the engineering department, whoever, and those people can then easily and conveniently look at the results. You don't have to print out a ream of PDFs or, pages of numbers and all that. This is an easy, concise presentation of the data. Okay, now let's say I didn't want to do it that way. I have the test set on a local network, and I don't want to bother copying to drives and transferring back and forth. I can use the FTP feature of the CTMP data viewer. First, what I need to do, so if I don't start the FTP server, and I click this, I'll get an error message. So I don't want to do that, so I want to start. I'll get a little box here that tells me what I did wrong. Okay, so what I do is I want to go to the aux menu on the test set and start the FTP server. Okay, the FTP server is started, so having this IP address is the IP address that your router assigns to the CT test set on the local network. This will be constant. We'll do the same thing for that same address for that MAC address every time, or you can set the router to make it that way. This is held in a text file called ip.txt. The only thing in the file right up at the top, the first thing you'll see in the file when you get it, is this IP address. You just edit it to use the IP address that your router assigns. So I'll click FTP, and there I have the same data, the same results as I had before on the flash drive, and it operates in this, I won't repeat myself, but it operates in the same way as it did loading the data from the flash drive. I'm on C phase now. And I can also add a result and so on. In addition, it saves the data. I have other data in here. It saves the data with CT followed by a random number. So what you would do at this point is find the data that was just saved, and you would rename that file so you could identify it later by the job, like maybe CTLV for Las Vegas, 230 for the breaker, LOA for load A phase, or LO if it was just A, B, and C. So you have your own conventions of file naming so you can find this stuff. This is, your administrative method that you would apply. And that is all there is to it. Thank you for watching.